Good evening. One student has asked me to discuss some more problems and prove that. I thought I just got one or two. There's a request from a student to work some more problems and prove that. I'll just work one or two problems today on that. After that I'll move on to logarithmic. I repeat what I said. There is a request from a student to work some more problems on prove that one or two. So first I'll work one or two problems of chain rule where it is prove that. After that I'll start. After that I'm going to start the differentiation of logarithm function. Take the first problem. If y is equal to log of a plus b tan x, divided by a minus b tan x, prove that dy by dx equals 2ab over a square cos square x minus b square sin square x. So as usual, whenever logarithm functions are given, think of a formula which you can use. So we are going to use the formula log m by n. Yesterday we have discussed log m by n is equal to log m minus log n. So it is used here. This is log of a plus b tan x minus log of a minus b tan x. Let us differentiate this. dy by dx is equal to log is 1 over a plus b tan x. Now you should differentiate a, which is 0. B is a constant, tan x is secant square x. Differentiation of a is 0. B is a constant, keep the constant, differentiate the function, tan x is secant square x. Minus 1 over a minus b tan x into difference of a is 0 minus b secant square x. Because b is a constant, keep it as it is. I think we can take out b secant square x common. So what do we get? 1 over a plus b tan x minus 1 over a minus b tan x. Now take the LCM. b secant square x over a plus b tan x into a minus b tan x. That's LCM. You get a minus b tan x plus a plus b tan x. So plus b tan x and minus b tan x will cancel. You get 2ab secant square x over a square minus b square tan square x. Now look at the answer. The answer is in terms of sin and cos. We are going to answer in terms of tan. So let us convert tan into sin and cos. So what will happen is 2ab secant square x into cos square x over a square cos square x minus b square sin square. I'll explain how I got this. I will write this tan square x as sin square x by cos square x. We'll take the LCM, that LCM will go to numerator. So the a square cos square x minus b square sin square x. The secant square x and cos square x are reciprocal function. Therefore, we get the answer. Let us work one or two more because there is a request for this from the students. I'll just choose some problems which let's go to the next problem of prove that. Y is equal to sin inverse of course, these sets of problems are normally not given in the examination. Normally, they are a little more standard because some student wanted to, I'm just working this. So they get little more idea about the chain rule and simplification also you can improve. A plus B cos x, you will not find this in NCERT book. They may not ask, but by working this problem, you will have better knowledge of the subject. Sin inverse of A plus B cos x over B plus A cos x. Prove that dy by dx is equal to minus root of B square minus A square divided by B plus A cos x. So you have to recall this. When y is equal to sin inverse x, dy by dx is 1 over root of 1 minus x square. So if you apply that here, 1 over root of 1 minus a plus b cos x over b plus a cos x whole square, which I write separately for our understanding. So I have differentiated sin inverse. Now I must differentiate a plus b cos x over b plus a cos x. You have got to use the quotient rule. So keep the denominator as it is, b plus a cos x as it is. Differentiate numerator. A is 0, cos x minus sin x. B is a constant, minus b sin x. Minus, keep the numerator as it is. A plus b cos x. Differentiation of b is 0, cos x minus sin x. Therefore, minus a sin x divided by b plus a cos x whole square. I'll just repeat what we have done. First, we should differentiate sin inverse. It is 1 over root of 1 minus x square. In place of x, you have got this. I have written it. Now, to enter inside and differentiate, it's a quotient rule problem. Keep the denominator. Differentiate numerator. A is 0, cos x minus sin x, therefore minus sin b sin x. Then keep the denominator, numerator, differentiate denominator. P is 0, cos x minus sin x. Now, what you can do is take the LCM here. When you take LCM, this will come to numerator, it becomes b plus a cos x. Now, why? square is there, but square root symbol we take out. Now let us write this expanding this itself. So this is b square plus 2ab cos it. I told you this is a little lengthy problem. Still I am working it so that you have a better idea of the simplification. So not only I am writing b plus a cos x whole square, I am expanding it. Minus, here also you have to be careful, you are expanding this. At the same time, you are multiplying by minus sign. Therefore, minus a square minus 2ab cos x plus b square cos square x multiplied by, we have a plus b cos x whole square here. Now, what do you get? You take sin x common. You have got minus b, so minus b square you get. Minus ab cos x. You have got minus a minus plus a square you get. Plus ab cos x. Those who are in the borderline for finding differentiation difficult, don't worry about this problem. Because there was a request from some student, but some more problems. I thought I'll give you a little more standard problem, which may not be asked in the examination. By working this, your knowledge of differentiation, especially the simplification part, will be improving. Now, I can cancel this a minus ab cos x and plus ab cos x. I can cancel b plus a cos x, 1b plus a cos x remain here. Here also 2ab cos x and that will also go. So what is that you get here? B square, here it is b square, a square. So what we can do is, if I take this b square and a square, b square cos x, I will get a 1 plus cos square x. But 1 plus cos square x has no formula. So I have to write it as 1 minus cos square x. So what I will do is, I will write this as, we'll take a minus, there's a mistake here. This is minus b square plus square x. Because there's a minus sign here. So I'll take b square common. Repeat. This is a square multiplied by minus sign, minus a square, plus 2ab multiplied by minus sign, minus 2ab, and plus b square cos square x, but there is a multiplication of minus sign. So therefore take b square common. You get 1 minus cos square x. You are grouping these two. Take minus a square common. You take minus a square common, you get 1 minus cos square x. So when I take minus a in common, this becomes plus 1. If you want, you can multiply and see, you get minus a square. This multiplied by a square minus b square sin x over a plus b cos x. Okay, you got whole square here, but you have cancelled with this. And repeat this b plus a cos x. When you take LCM, come here, I've expanded it. B square plus 2ab. Here, you have to be careful. It's not only expanding, multiplying by minus sign. Now, what do you get? B square into sin square x minus b square into cos square x. 1 minus cos square x is sin square x. So, I can write this as 1 over root of b square minus a square into sin square x. This is cos square x, 1 minus cos square x is sin square x. This is sin square x. This is also sin square x. So I have taken sin square x common. I get b square all within the root. What do we have here? a square minus b square sin x we have here divided by a plus b cos x. I don't know whether I've taken a wrong problem, but still I just wanted to work this so that some of the students who find problems for some substandard, they can really enjoy working this. Now what I do is, I will write this as minus of b square minus a square. Sin x, and take minus n common. This is root of b square minus a square into sin x. Because root of sin square is sin x. These two will cancel. You get 1 over a plus b cos x. So, but you can cancel this. You get root of b square minus a square. So, final answer is minus of b square minus a square over a plus b cos x. I will work one more problem. It's more standard. But still, I just want to work only to create interest. That's all. These kinds of problems may not be asked in the examination. It's only for our improvement. By working a difficult problem, your simplification will improve. 3 plus 5 sin x. All these problems are part of the second QC portions earlier in 2014. After 2014, they have reduced the syllabus, so things have become more easy. 4 over 3 cos x plus 5. These two problems, just to teach you how the chain rules works. Now, first you have to differentiate tan inverse. You know, if y is equal to tan inverse x, then dy by dx is 1 over 1 plus x square. We know that. So I am using this here. So this is 1 over 1 plus 4 becomes 16 sin square x divided by 3 plus 5 sin x whole square. Tan inverse x over 1 plus x square. In place of x, you have got this. So I am writing this. Now enter inside. Tan inverse is over. You need to differentiate this. The quotient. So keep the denominator 3 plus 5 sin x. Differentiate the numerator. That is 4 cos x. Keep the denominator as the numerator as it is. Differentiate denominator. 3 is constant. This is 5 sin x. 5 cos x rather. Because sin x differentiated is cos x. I'm sorry. The problem that I have written is wrong. It is not 5 sin x, it is cos x here. Please make a correction. 4 sin x over 3 plus 5 cos x happening. Therefore, this is not sin x. Please make a correction. The actual problem is 4 sin x over 3 plus 5 cos x, because cos x is in the answer also. Now, first differentiate tan inverse. Keep the denominator, differentiate numerator. Keep the numerator, differentiate denominator. You get 5 cos x is minus 5 sin x. Divided by 3 plus 5 cos x whole square. We'll explain once again. There was a mistake in copying the problem. The actual problem is 4 sin x over 3 plus 5 cos x. You got to prove this. Now tan inverse is 1 over 1 plus x square, which I have written here. Now this is quotient rule. I keep the denominator, differentiate numerator. I keep the numerator, differentiate denominator, divided by denominator square. That completes differentiation. Now you have to show your ability in simplification. Take the LCM. dy by dx is equal to, when you take the LCM, this will go up. 3 plus, this has to be corrected. This has to be corrected. This is cos x. So 3 plus 5 cos x whole square divided by, expand and write it, 9 plus 30 cos x plus 25 cos square x. If you find this difficult, don't get trouble, leave it. I'm working this only for those who really want to enjoy working some difficult problems. Now, you cannot take anything common, you got to multiply. So, but if you want, you can take 4 common, 4 is here also, 4 is here also. No. 4 can be taken as a common factor. So, if you take 4 common, here 4 is there, here 4 is there. So, what do you get? 3 cos x plus 5 cos square x plus 5 sin square x. I have taken 4 common, so 3 cos x plus 5 cos square x. I have taken 4 common, so 5 sin square x divided by 3 plus 5 cos x whole square. So these two you can cancel straight away. What do you get there? 4 into 3 cos x plus 5. Because sin square x plus cos square x is 1. You can take 5 common, you get 3 cos x plus 5, 4 is outside. So we have got 4. We should get divided by 3 cos x plus 5, but we have got in numerator. So it is very clear, you should get 3 cos x plus 5 whole square in denominator. So I will write this as 3 cos x plus 5 whole square. So if I cancel this, I will get the answer. But how you can write that? Very simple. You expand this, you get 9 cos square x. 9 cos square x plus 50, 30 cos x plus 25. But actual problem given is not that. How to arrive at this? You have got 3 plus 30 cos x and 25. You write 25 as 9 cos square x plus 16 cos square x. So 1 minute. 3 plus 5 cos x you should get. So 30 cos x. We are writing this as 9 cos square x plus so let us write 9 as 9 into sin square x plus cos square x plus 30 cos x plus 9 sin square x plus 16 cos square x. So let us not waste time, I will just give you the method. By simplifying this, you can get this. Because when you go for the simplification, it takes more time. I'm just leaving it here. You can write this. by adjusting terms. How do you adjust terms? You should get 9 cos square x plus 25. So 25 is written as 16 and 9. And you can add the 16, then you will get 9 cos square x. So this should be, when you simplify this, you should get 9 cos square x plus 30 cos x plus 25. That is 3 cos x plus 5 whole square. That you have got your test. Okay. So with this, we'll move on to the next problem. Because this simplification part you can do it. Write cos square x is 1 minus sin square x and then convert it. You get the answer. Okay. We'll work one more problem on chain rule, where we got to prove something. I've taken some difficult problems today. Y is equal to tan inverse of cos x over 1 plus sin x. Prove that dy by dx is equal to minus. I just want to teach you this by two different methods. First one is dy by dx is equal to 1 over 1 plus cos square x over 1 plus sin x whole square multiplied by 1 plus sin x into cos x is minus sin x. Keep cos x as it is, you get 1 is 0, sin x is cos x. Divided by 1 plus sin x whole. I want to make it clear once again, I have not shown the simplification. In case if you don't get it, and if you ask me to simplify, I'll do it tomorrow. Just to save time, I'm not. This expression will simplify into this, which I have not shown. But if you want, I'll just do it. If any request is there to show me the simplification tomorrow. Okay. Now, so this is dy by dx is equal to. When you take LCM, this will come to numerator 1 plus sin x whole square will come to numerator. This is 1 plus 2 sin x, 2 sin x plus cos square x plus sin square x. I'm expanding this. A square is 1, 2ab is 2 sin x, and sin square x. The cos square x is there. I'm just putting a bracket so that you can simplify that. Here it is minus sin x minus sin square x minus cos square x over 1 plus sin x whole square. These two will cancel. This is 1, therefore this is 2 into 1 plus sin x. Here, if you take minus sign common, you get 1 plus sin. How? Sin square x plus cos square x is 1. So what will happen is these two will cancel, you get minus 1. So repeat, first differentiate tan inverse, then use quotient rule and simplify. But I want to teach you another method, simple method for this. You know this formula. Sin A is 2 sin A by 2 cos A by 2. 1 plus cos A is 2 cos square A by 2. So here they have given cos x. There they have 1 plus sin x. So they are given 1 plus cos x. Simplification would have been easier for us. So what we should do is convert it. You can write cos x as sine of pi by 2 minus x. And write this 1 plus sin x as cos of pi by 2 minus x. For our understanding, we will say put pi by 2 minus x equals alpha. Only for our understanding, working becomes easier. Every time instead of writing pi by 2 minus x, I am making my work easy by writing it as alpha. So y is equal to tan inverse of sin alpha or 1 plus cos alpha. What is sin A? 2 sin A by 2 cos A. Okay, let us use that formula. Tan inverse of 2 sin alpha by 2 into cos alpha by 2. What is 1 plus cos A? 2 cos square alpha by 2. Now 2 I can cancel, 1 cos I can cancel. I get tan inverse of tan alpha by 2, which is equal to alpha by 2. But what is alpha? Therefore, it is pi by 4 minus x by 2. Therefore, dy by dx is equal to pi by 4 is 0, it is minus 1. So, by using trigonometry, these problems become simpler. So, I have worked these problems because there was a request from a student asking me to work one or two, and I have chosen some difficult problems. The main reason, those problems, if you work, will definitely improve your ability of simplification. And some of you are finding the basics difficult. Forget about those problems. There is no point in wasting time on it. Okay? Let's continue what we had planned for today. Logarithmic function. Of course, yeah, differentiation of logarithm functions. So before we start working problems, we'll recall the formulas of order. Remember, the basic requirement for working in this. What is the first law of logarithm? Log m plus log n is equal to log mn. We have not written any base. That means base are same, but in calculus, even if the base is not written, it is always e. What is second law of logarithm? Log m minus log n is equal to log m by n. What is third law of logarithms? Log m power n is equal to n log m. What is the fourth law of logarithms? It is also called change of base law. Log m to base n is equal to log m by log n. You can write any base. Then you should remember log 1 to any base is 0. The second one, log of the number to the same base is 1. If you have these ideas, then we can work problems on logarithms. So let me start with a simple problem on logarithms. Take the first problem. Or if you want, you can just make a note. Note, we use laws of logarithms to differentiate the functions of the following types. First one, y is equal to f of x to the power of g of x. The power is also a function of x. For example, when I have got y is equal to x to the power of n, dy by dx is n x to the power of n minus 1. But n is a number here, it's a rational number. But here, example probably x to the power of x. You cannot use this formula. I cannot write x to the power of x minus 1. Why? X is not a number. You should remember that here this is applicable when n is a rational number. The second one, y is equal to f1x into f2x into etc. fnx. The third one, y is equal to f1x into f2x etc. fnx divided by g1x into g2x etc. gnx. Etc. There are other types also, just taken 3 cases. So whenever you notice problems having power is also a function of x, then use logarithms. So let me start with a very simple problem. The first problem is y is equal to x to the power of x. Taking log on both sides. Log y is equal to x log x. Which formula I am using? Log m power n is n log m. Therefore, now logarithm of log y is 1 over y into dy by dx. Same procedure. First, you should differentiate log into 1 over y is dy by dx. What about x log x? It's a product. Use product rule. Keep log x as it is. Differentiate x, you get 1. Put a plus sign. Keep x as it is. Differentiate log x, you get 1. So what do you get? dy by dx is equal to y into 1 plus log x. But what is y? X to the power of x. 1 plus log x. So you can remember this as standard formula. I think we have listed about 18 or 19, whatever number, supposing it is 18. You can add this into that list. Y is equal to x to the power of x. dy by dx is equal to x to the power of x into 1 plus log x. Here afterwards, we can use this as a standard form. Now, let's go to the next problem. Y is equal to sin x to the power of cos x. So again, the problem of f of x to the power of g of x. Therefore, take log y is equal to cos x into log sin x. Same procedure, differential log y is 1 by y is dy by dx. This again product rule. So keep log sin x as it is. Differentiate cos x, you get minus sin x. Keep cos x as it is. Differentiate log sin x, you get 1 by sin x. Log is 1 by sin x. Sin x is cos x. So this dy by dx is equal to y into minus sin x log sin x plus cos x into cot x. You need not simplify, you can leave it like that. Let's work one more problem. Tan x to the power of, take log on both sides. I am rushing through because these are all very simple problems. Cot x into log tan x. Log y is 1 by y dy by dx. Again, product rule. Keep log tan x as it is. Differentiate cot x, you get minus cosecant square x, that you need to remember. Then keep cot x as it is. Log tan x is 1 over tan x into secant square x. Now what is dy by dx? I will make my work very easy. This is y into entirely okay. I am just shifting this y here, the entire thing as it is. There is no enough any simplification. So like this you can work sin x of tan x, whatever it is given. When you notice it's the problem of function to the power of function. This is first category. The next one is y is equal to sin 4x into sin 6x into sin 8x. A problem like this is given. So I have already given a second time y is equal to f1x and f2x, etc. So take log on both sides. This is log y is equal to log sin 4x plus log sin 6x plus log 8x, sin 8x. How? We know the formula. Log mn is log m plus log n. This one formula can be extended also. Supposing I got log m n p etc etc. This is equal to log m plus log n plus log p. The formula can be extended in number of terms. So I have applied that formula. Now, what next? Differentiate this 1 by y dy by dx. Log sin x is 1 over sin x, 1 over sin 4x, and sin 4x is 4 cos 4x, plus 1 over sin 6x, and this 6 cos 6x, plus 1 over sin 8x, this is 8 cos 8x. So what is your final answer? Dy by dx is equal to 4 cot 4x, 6 cot 6x, plus 8 cot 8. I'll take one more problem. X minus 3 to the power of 4 into 5 minus 2x to the power of 5 into 3x plus 7 to the power of 3. Again, you notice it's f1x and f2x, etc. So you can take log y is equal to 4 log x minus 3 plus 5 log 5 minus 2x plus 3 log 3x plus 7. Let us differentiate this. 1 by y dy by dx is equal to, this is x minus 3, differentiation of x is 1, this 4 is as it is, plus 5 is as it is, differential minus 2x is minus 2, therefore this is minus 10. I repeat, denominator first you write it 5 minus 2x, because log is 1 over 5 minus 2x. Now 5 is, keep 5 as it is, derivative 5 is 0, x is 1, minus 2x minus 2, then minus 10, plus 3x plus 7, and this is 9. As I said earlier, what is our final answer? Y into, you can write this as this. We'll move on to the next problem. These problems are very simple. Only thing is you need to realize you have to apply logarithm, and you also need to remember the laws of logarithms and basic differentiation, or you know it. So this is hello. ಬನ್ನಿ ಇದ್ದಾರೆ ಮಕ್ಕಳಿದ್ದಾರೆ ನನ್ನ ಕ್ಲಾಸಲ್ಲಿ ಹೇಳ್ತೀನಿ. ಶಿಲ್ಪ So next problem, y is equal to 4x minus 3 to the power of 2 by 3 into 5 minus 7x to the power of 7 divided by 5 minus 8x 5 minus 8x to the power of 3 into 4x plus 5 to the power of 3 by 2. I just trying to make it a little more complicated so that when you work these problems, the problems that you get in examination will be handy for you. Okay? Again, you notice it's which formula I got to use? The third one which I have given. f1x and the f2x etc. fnx divided by g1x, g2x. So you should remember the formula. The two formulas we are going to use. Log m by n is log m minus log n, one formula. The other formula we are using is log mnp is equal to log mn is equal to log m plus log n. The third one we are using is log m power n is equal to n log m. So all the three formulas we are using. To make you understand, I am writing all the steps for the first problem. When I work the next problem of the similar type, I will show you which are the steps you can avoid. Here, when I work this problem, the working may appear a little lengthy. I am writing this to make the concept very clear to you. When I work the next problem, I will avoid all the unnecessary steps and show you how you can reduce the number of steps. The first thing is the entire thing numerator is called as m, the denominator is called as n. Therefore, when you take logarithm, log y is equal to log of numerator 4x minus 3 to the power of 2 by 3, 5 minus 7x to the power of 7 minus log of 5 minus 8x to the power of 3 into 4x plus 5 to the power of 3. I am writing all the steps for the first problem. Now, log y is equal to, You have to apply log A, log AB formula. That is log A plus log Mn formula. So the first step is log 4x minus 3 to the power of 2 by 3 plus log 5 minus 7x to the power of 7 minus log 5 minus 8x, put a bracket because the minus sign, 5 minus 8x to the power of 3 plus, the bracket is required because of the minus sign, 4x plus 5 to the power of 3. I am writing all the steps. The next step is this is as it is. This is 2 by 3 log 4x minus 3 plus 7 log 5 minus 7x minus 3 log 5 minus 8x plus 3 by 2 log 4x plus 5. There's a minus sign. Now 1 by y dy by dx is equal to 2 by 3 is a constant. So this is 4 over 4x minus 3. How do you get 4? First logarithm is 1 over. Differentiation of 4x is 4. 3 is a constant. 7 is a constant. This 5 minus 7x. Derivative of 5 is 0. Minus 7x is minus 7. Minus 3. This is minus 8 over 5 minus 8x. Of minus 8. First log is 1 over. 5 is 0. Minus 8x is minus 8. Plus 3 by 2 as it is. This is 4 over 4x plus 5. Now let us simplify this. dy by dx will be equal to 8 over 3 into 4x minus 3 plus 49 over 5 minus 7x. Not plus, minus, because the minus sign is minus 49. But this is plus 24 over 5 minus 8x. You can cancel this. Plus 6 over 4x plus. Now this 1, 2, 3, 4, 5 steps are there. But what I suggest is, if you can understand these 2 steps, you need not write. You can directly write this. Oh, there's a mistake. This is minus. This also minus. Because there's a minus and outside. So directly you can write this step and continue. So to make it more clear, I'll work one more similar problem. I will take problem with fractions. So y is equal to 4 minus 5x to the power of 7 by 3 into 6x plus 5 to the power of 3, 7 minus 4x to the power of 5 by 2 into 3x minus 4 to the power of 7. Now I will try to avoid some of the steps, still you can follow because I have given the detailed steps in the previous problem. First step I am writing here is log y is equal to 7 by 3 log 4 minus 5x plus 3 log 6x plus 5 minus 5 by 2 log 7 minus 4x minus 7 log 3x minus. Let's explain how we got it. Log m by log is log m minus log m. So when I take minus log m, I should get minus n for both of them. But this is when I take log m power n log m. See, when it is 3 log. And why should I write a minus n? Because log m by log n is log m minus log n. So these two terms are negative. So what is your answer? dy by dx is equal to directly you shift y. You know 1 by y is getting shifted. You can shift that. And this is 4 minus 5x 3 into 4 minus 5x minus 35. I am writing it directly. 7 by 3 is a constant. Log is 1 over 4 minus 5x. The differentiate for it is 0. The differential minus 5 so it minus 5. Minus 5 to 7 is minus 35. Plus 6x plus 5 denominator. Numerator is 18. How do we get 18? 1 over log is 1 over 3 is a constant. 6x is 6, 5 is 0, 6 is 18. Minus 7 minus 4x. 7 minus 4x. You are getting minus 4, therefore this will become plus. This is 10. Let's tell how. You got minus 5 by 2. Differentiation of 7 is 0, you get minus 4. You can cancel this. All these you should learn to do it orally. And here it is 21 over 3x minus 4. So this is solution. Though this problem carries 4 marks, you can work it out in 2 steps, still they get marks. It is not based on number of steps. We have not jumped any step. We have just among the steps we are doing mentally. For example, here 5 by 20 minus 4 or 10. How do you write a plus sign? You get a minus sign. So spend 1 more minute extra on differentiation so that you can avoid. I will move on to the next problem. Y is equal to square root of x minus 3 into x minus 4 divided by x minus 5 into x minus 6 into x minus 7. So when root is given, you should realize this problem is of this type. X minus 4 into x minus 4 divided by x minus 5 into x minus 6 into x minus 7 whole to the power of 1 by 2. So the first thing you should realize, so when you are taking logarithm, it is log y is equal to half log x minus 3 plus log x minus 4 minus log x minus 5 minus log x minus 6 minus log x minus 7. This must be your first step. But if you have got difficulty, I'll explain how I got this. So when I take log m power n is n log n. Therefore, I have written half outside. Now, log a by b or log m by log n is log m minus log n. And again, I am using log m n is log m plus log n. Why do I get a minus n for all the three? That is the denominator. Now, what is our answer? dy by dx is equal to y by 2 into 1 over x minus 3 plus 1 over x minus 4 minus 1 over x minus 5 minus 1 over x minus 6 minus 1 over x minus 6. Normally this problem carries 4 marks in examination. I've taken a simple problem. I'll take one more problem of the same type. Y is equal to 4 minus 5x plus root of into 6x plus 7 divided by 3 minus 8x into 4x plus 5. Same procedure, we have to take log. I am writing directly the first step what you should write. I am writing the step directly and also explaining how I got this, but you must be able to write the step directly. First step is log y is equal to half outside y, root means power is half. Log 4 minus 5x plus log 6x plus 7 minus log 3 minus 8x minus log 4x plus 5. Just repeat what I did. The first thing is I just wrote this root as power half. And I am using the formula log m power n is n log n. So half is outside. Then log m by log n is log m minus log n. Then log mn is log n. So log m plus log n. You get minus sign for both of them because those two terms are in denominator. So what is your next step? dy by dx equals y by 2 is 1 by y and directly shifting here. This is minus 5 over 4 minus 5. Very careful. The previous problem, all the numerators were 1 because the coefficient of x was 1 and all x were positive. That is why to make the point very clear, I have taken some positive and negative. So log is this, differentiation of 4 is 0, minus 5x is minus 5 plus 6 over 6x plus 7. How? Derivative of 6x is 6 and log is 1 over. This is plus 24 over 3 minus 8x. How? Log is 1 over. Derivative of 3 is 0, minus 8x is minus 8, minus 8 into minus is plus. And this is minus 4 over 4x plus 5. So logarithm problems are comparatively easy. Only thing is you have got to use the laws of logarithm and use the corresponding chain rule. These are chain rule only, but simple chain rule. With the problem that we work in chain rule, these things should not appear difficult for you. Now let's go to the next type of problem. If you are given a problem, x to the power of x plus a to the power of x plus e to the power of x plus a to the power of a. Supposing a problem like this is given for 1 mark, normally they ask this for 1 mark. The moment they see the student think that they can apply log on both sides, no, definitely not. Because there is no form, we have a formula log mn is log m plus log n. But we don't have a formula log m plus log n is log m plus log n. This formula is not there. So these problems is given just to confuse you. Look at each term. They are all standard. derivatives. Therefore, you can use addition. dy by dx is equal to, I told you should remember, this is x to the power of x into 1 plus log x. A to the power of x is a to the power of x into log a to base e. A to the power of a is a constant, therefore it is 0. So this is a problem normally given in for 1 mark. So you should realize they would have, supposing they have given some other term, they have given us x to the power of sin x or something else. What to do? They won't give. If they give that, they will not give 4 terms, they will give 2 terms. That problem I am going to teach now. There is another category of problem. The next category of problem is, you are given a problem like this. Sin x to the power of cos x plus cos x to the power of sin x. These are all standard problems. Don't apply logarithm and say log y is equal to cos x, sin log x plus sin x, log cos x. If you write that, exam is very happy because he can scratch and go to the next problem. Many students have lost marks in this. Even some of the students have, when I have gone for valuation, I have seen, I don't know what happens to them. The moment they see a power, the power is also a function. So they know they have to apply logarithm. But there is no formula for log n plus n. So these types of problems you need to remember. The method for this is let y is equal to u plus b. What is u? U is sin x to the power of cos x. What is v? V is cos x to the power of sin x. Here you write, then dy by dx is equal to du by dx plus dv by dx. So this is the first step. For those students who have got difficulty in differentiation, or in the border case, I always tell them, when you notice a problem like this, even if you don't know differentiation properly, anybody can write y is equal to u plus v like this, write this, you get 1 mark for that. Then you can make an error, this is a power function, therefore I can take log, then you can continue to the extent possible. So these are all problems where students can easily get 100 marks. And we're talking more about this when I take the examination papers. I always repeat this. The object of the classes that I am conducting here is to improve the percentage of results, to reduce the number of failures. So I am concentrating more on that. The areas where a student with minimum knowledge can get the marks. This they can remember. The moment they might have given sin x or whatever it is given, a problem like this. Writing y equal to u plus v and dy by dx is equal to that formula is, and writing this is not difficult. Afterwards, you can make a small attempt what is possible. Log u is equal to cos x log sin x. We are taking log on both sides. Here, log b is equal to sin x log cos x. Now, 1 over u du by dx is equal to, you keep log sin x so you can use product rule for this. Keep log cos x log sin x. Cos x is minus sin x plus keep cos x. This is 1 over sin x into cos x, that is cos x. I repeat, log sin x is 1 over sin x into cos x, That is cortex I am writing indirectly. Here 1 over v dv by dx is equal to keep log cos x as it is, sin x is cos x plus keep sin x as it is, cos x is log cos x is minus tan x. I'll explain how. Log cos x is 1 over cos x is minus sin x, therefore minus tan x. What is the next step? Du by dx is equal to, u comes here, but you know u is sin x to the power of cos x into minus sin x log sin x plus cos x into cot x. What about dv by dx? That is equal to v. What is v? Cos x to the power of sin x into cos x log cos x minus sin x tan x. The problem is not over. You have to find you have to find dy by dx, that is equal to du by dx plus dv by dx. You have to write this term plus this. But I will not waste time. So what I will do is I will manage with this only. But you can't do this examination. This is for my work to be simple. I write dy by dx here. These two. So I have one more problem of this type. Y is equal to x to the power of sin inverse x plus sin inverse x to the power of x. So they can give any functions, but it's a problem where you have got to use logarithm, that you should realize. So what is your first step here? The first step here is let y is equal to u plus b. U plus b. Then dy by dx is equal to du by dx plus dv by dx. Now, what is u? X to the power of sin inverse x. What is your v? Sin inverse x to the power of x. So take log u is sin inverse x into log x. Here log v is x into log of sin inverse x. So 1 over v u du by dx is equal to, it's a product. Keep log x as it is, differentiate sin inverse x, you get 1 minus x square. Keep sin inverse x as it is, differentiate log x, you get x. This is du by dx. 1 over v dv by dx, keep log sin inverse x as it is, differentiate x, you get 1. Keep x as it is, differentiate log sin inverse x. This you should understand. Log is 1 over x I have kept as it is, log is 1 over sin inverse x and sin inverse x is this. So what is your final answer? I am going to write the final answer. You can write other steps yourself. U is x to the power of sin inverse x into log x plus root of 1 minus x square plus sin inverse x by x plus sin inverse x to the power of x into log sin inverse x plus x over sin inverse x into 1 over root of 1. I have not written some of this stuff, but you can make it out. So these problems, when asked in examination, they carry 4 marks. Let's move on to the next type of problem. Here they can give any function, tan x to the power of 40, whatever it is. Procedure is same. What is the minimum requirement for you? You should know the logarithmic laws and basic derivatives and chain rule. The other type of problem they gave is find dy by dx. If y to the power of x is equal to x to the power of y. Very simple problem. This is x log y, taking log, x log y is equal to y log x. Both are product rule. Keep log y, differentiate x, you get 1. Keep x, differentiate y, 1 over y into dy by dx. I am using product rule. Keep log y, differentiate x, you get 1. Keep x as it is, x you have got it as it. Keep x as it is, differentiate log y 1 by y, and y is dy by dx. Here, keep log x as it is, differentiate y, you get dy by dx. Keep y as it is, log x is 1 by x. Now take the terms containing dy by dx on one side. Dy by dx into x by y minus log x is equal to y by x minus log y. So this is dy by dx is equal to, if you take the LCM, x minus y log x. If you take the LCM, x over y minus x log y. So what is your final answer? Dy by dx is equal to y into y minus x log y divided by x into x minus y log x. So instead of a problem like this, I can also give you a problem. Sin x to the power of x is equal to cos x to the power of y. Something like this. Same procedure you can follow. But I take another problem, which is a standard problem, usually asked in examination. Xy is equal to e to the power of x minus 1. This is a problem in the NCERT textbook also. So you have to take logarithm. So it is log x plus log y is equal to x minus 1. How? When you take log of xy, this is log x plus log y, you know the formula. When you take log of m power n, this is n log m, you know. So when you take log of e to the power of x minus y, it is x minus y log e. But log e to base e is 1, therefore I am not writing it. It is log e to base e, and logarithm of a number with the same base is 1. Now you can differentiate this. 1 over x plus 1 over y dy by dx is equal to 1 minus dy by dx. Take dy by dx on one side. 1 by y plus 1 is equal to 1 minus 1 by x. So this is dy by dx. Y is LCM 1 plus y. Here x is LCM x minus 1. So dy by dx equals y into x minus 1 by x into 1 plus 1. So most of the problems in logarithms are very simple. Today I just want to introduce parametric equations and just solve one or two very simple problems so that you can prepare and come for the next class. After parametric, we are going to do second derivative problems. Maybe by Friday, we will be able to complete. Maybe by Friday, I will be able to complete this revision part, unless there is any request from the students to work more problems. Today, I worked some problems and through that, there also I have just left one problem, not simplified, just leave it to you, just to save time. In case if you have not got the solution, 3 cos x plus y whole square, I'll work it out for you next class. Okay. Now, I'll just introduce logarithm and parametric functions. Just work one or two problems because we have got about 5 minutes time. And tomorrow, Saturday, we can start working the started problem. So, differentiation of parametric functions. I'm just giving this so that tomorrow, Saturday, we can go to the problems. In certain cases, the two variables x and y are expressed, two variables x and y are expressed in terms of the third variable theta or t. Here theta or t is called a parameter. So here x and y are not directly related. X and y are related to t. X is related to t and y is also related to t. Finally, we have to find dy by dx, the change of y with respect to x. Example. Y is a function of t. X is a function of t. So what we do is, we find dy by dt, that is f dash t. We find dx by dt, that is g dash t. We want dy by dx. This is dy by dt divided by dx by dt. That is f dash t by d dash. Is it t or theta? Normally we use T, one of them. No other, only T of theta. So let me work about 3 minutes are there. Just one or two problems to make this concept clear. The first problem. Find dy by dx. If y is equal to ad square, x is equal to 8. The moment you see the problem, it's very clear, it's a problem of parametric. So it's as good as working two problems. I am finding dy by dt. If it is x square, I would have got 2x. Because it is 2t square, I get 2t. A is a constant. Similarly, dx by dt. In place of y, supposing you have got y is equal to 2a x. I would have written dy by dx is equal to 2a is a constant, x is 1. Same thing, only difference is in place of y you have got x and in place of x you have got t. Therefore, this is 2a, t is 1. Here, x with respect to x is 1, then t with respect to t is 1. We want dy by dx. That is dy by dx, dy by dt divided by dx by dt. That is 2at divided by 2a. Just work one more problem and stop. Find dy by dx. X is equal to a tan theta, y is equal to b secant theta. So I will find dx by d theta, not t, because variable is a is a constant, tan theta is secant square theta. A secant square theta. Here I find dy by d theta. Secant theta is secant theta tan theta. Now we have to find dy by dx. That is dy by d theta divided by dx by dt. So dy by d theta is e secant theta tan theta. Dx by d theta is a secant square theta. So one secant theta cancels. Further also you can simplify. You can write this as b sin theta by a cos theta into secant theta. So you can write tan theta sin theta by cos theta comes in denominator. You write it as it is, but you know that secant theta and cos theta are reciprocal. The answer is b by a sin theta. With this, I am closing class today. I have just introduced parametric and I have taken just two simple problems. So tomorrow we'll go ahead with other standard problems. And in case if you are able to complete parametric tomorrow, I will start successive. Depends. So thank you. Good night. We shall meet tomorrow. Is there any queries? Is there anything you can send a message so that I will. Yes, as last two classes, there was one message was one more problems on chain rule. The other message was some more problems of Prudhoe which I have done it. So today there is no message, so we'll wind up the class. Meet tomorrow at 7 o'clock.